Example number 3. 3 times 10 to the 2x minus 5 minus 48 equals 10. And why is this guy an exponential equation? He has an x trapped up in his exponent. It is type 1 because it's only one guy with x in his exponent. Next, we're going to do a type 2 where there are two guys with x in their exponent, and our directions for those guys will be different. Okay, and if we only have one guy with x in his exponent, we get the guy with x in his exponent all by himself. And so my first step in making that happen here is to plus 48 plus 48. That gives me 3 times 10 to the 2x minus 5 is equal to 148. Next, my guy with x in his exponent is not all by himself. Side note, this 3 cannot multiply times this 10. We can only multiply when we have the same base and add the exponents. This is not a 30 raised to the 2x minus 5. We do need to get the guy with x in his exponent all by himself. By the opposite of times 3 is to divide by 3, divide by 3. That gives us 10 to the 2x minus 5 is equal to 148 divided by 3. 148 divided by 3, according to my calculator, is not a nice number. So I guess we're going to leave it 148 divided by 3 for now. Okay, next. And it's a fraction that doesn't reduce because 3 is a prime. Next, I am asking myself, can I write both sides in the same base? 10 is my base, and 148 divided by 3, I don't think is a base 10 guy. And so if I can't write both sides in the same base, then I log base b both sides. Who is my base b this time? My base is 10. So I am going to log base 10, 10 to the 2x minus 5. I do just want to remind you that log base 10 of 148 divided by 3. Log base 10 is not usually written log base 10. Log base 10 is just log. I will accept it either way. But log of 10 to the 2x minus 5, the reason that we are log base being both sides is because log base 10 of 10 to the 2x minus 5, log base 10 of 10 cancels and 2x minus 5 falls out. That is equal to log of 148 over 3. I cannot put that in my calculator and get a yucky decimal until the very end because I am asking you for an exact answer. You are headed to calculus, and there we do exact answers, exact answers, exact answers. We don't like yucky decimals unless we have to. So next I'm going to plus 5, which gives me 2x equals log of 148 divided by 3 plus 5 is outside there. Next, to finish solving for x, we're going to divide by 2 to get x equals log of 148 over 3 plus 5 all over 2. And this is my exact answer. But log is a button on my calculator, so I don't have to use the change of base formula this time. I only use it if necessary. I type this whole thing in my calculator and get his decimal approximation rounded to 4 decimal places. Again, You do need to know how to work your own calculator. Log of 148 divided by 3 in a parenthesis. Plus 5 is outside of that. I need to hit equals because I should have put a whole parenthesis around all of that. Then divided by 2. And x is approximately 3.346. There's a 5 there with a 7 next door. Tells him to round up to a 6. So 3.3466 is our approximation. Okay, next. Type 2 of our exponential equations. Type 2 is when more than one guy has an x in the exponent. More than one guy has an x in the exponent. Now, there are two types of type 2. More than one guy has an x in the exponent. What you need to ask yourself are there only guys with x in the exponent? Like, there is one term here and one term here, and they both have x's in their exponent. Example number 5, however, x in the exponent, x in the exponent. Oh, look, there's an extra guy that doesn't have an x in his exponent. So, is there an extra guy floating around with no x in the exponent? Is there, hold on, I'm trying to remember my formatting. Is there an extra guy floating around with no x in his exponent? If yes, I'm going to save some room for there. If no, I'm going to say keep them on opposite sides of the equal sign. Keep them on opposite sides of the equal sign. With no x in his exponent. Side note, if he's 0, that doesn't count. So, exponent. Other than 0. If yes, If no, make sure the guys with x in their exponent are on opposite sides of the equal sign. Make sure the two guys with x in their exponent are on opposite sides of the equal sign. of the equal sign. And once they're on opposite sides of the equal sign, then you are going to ln both sides. Ln both sides. So we are going to ln 7 to the negative 4x plus 1 equals ln of 2 to the 4 plus 3x. Use the properties of logs to pull down your exponent. Use properties of logs to pull down exponents. We're going to say pull down exponents in a parenthesis. Or in, not a, but in parentheses. People screw these ones up all the time because they don't put the parentheses. And so what that's going to look like is properties of logs allow us to pull these guys down to the front. Right? That's what we're going to do. And when we pull down negative 4x plus 1 times ln of 7 equals 4 plus 3x times ln of 2. When we pull those exponents down, they need to be in parentheses. I cannot stress that enough. It is incorrect without doing that. I think my video's gone a little long at this point, so I'm going to pause and then do the next part.